So for the final week of probability, we're going to be taking a look at basically how many different ways can you arrange things. When you think about stuff like lock combinations and things of that nature, you might look at one of those basic locks and say, how many different combinations are possible? That's what we're going to be working on today. This is a topic, I think it's called combinatorics, and it gets used in a lot of different applications. But let's take a look at some simple examples. We'll get more in depth this week. It says a pick 6 lottery has you pick 6 numbers 0 to 9. How many possible combinations are there? Well, how many ways can you pick the first number? Well, I could pick a 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it seems like there are 10 possible combinations. Times the second one, 10, times the third one, 10, times the fourth one, 10, times the fifth number. There's another 10, times the sixth number. Now we have a nicer way to write this. We can represent this as 10 to the 6th power. When I do that in the calculator, so I can do 10, and then we raise that to the 6th power, and this is going to give me it didn't give me scientific notation. It might, but it seems like there are a million different possible combinations. So there are 1 million combinations. So the next problem says, what is the probability of selecting the winning combination? Well, for this problem, we're going to think about this as the winning combination means you have to get them in the correct order. So maybe a number like 5, 7, 9, 3, 6, 1. Like that would be the winning combination. How many different ways can you get that number? Well, there are only one way to get that number. Out of how many different possible combinations are there? There are a million. So if you do a pick 6 and you got to get them in the exact correct order, your probability of winning would be 1 out of a million. Now we'll talk about if order doesn't matter here in a second. The next problem says, how many ways can you arrange 5 books on a shelf? Well, for this problem, we're going to be taking a look at a different type. Arranging 5 books on a shelf, you could try to think about them as, let's think about the different books as A, B, C, D, and E. So you got to think about it. If I switch D and E, I'm going to get a different combination. If I switch A and B, I'm going to get a combination. There are a lot of these. And it's going to be really difficult for me to count all of these and keep them straight. So I'm going to show you a mathematical technique to help us calculate this. If we are just trying to figure out how we can arrange a certain number of things, that is calculated by finding the factorial of that number. So I know this looks like a very excited 5, but what this stands for is it's actually 5 times 4 times 3 times 2 times 1. And again, we could do this in our calculator, but actually, if you take a look, so if you have a TI-30, I'm going to show you, depending on which one you have, if you have a TI-30 that looks like this one up here, if you hit this probability button right here, you can find the factorial. So if you hit 5 and then go to your probability and select that correct function, it's there. If you have this TI-30, you're going to hit second and then the number 3. So you put 5 and then you hit the second key and then press the number 3 and then enter. And I think that will calculate your factorial for you. If you have a TI-84 or 83, what we're going to do is we're going to put 5 and then we go to math. And then we're going to arrow over to probability, and we're going to select the number 4. And then I hit enter. And so we can see, again, we could do 5 times 4 times 3 times 2 times 1. That will give us the same thing as what we got here, which is 120. So we're going to be working with the calculator a decent amount in this section, so you want to make sure that you know where your buttons are. So this next one says, if there are 9 players on a basketball team, how many different lineups of starting 5 players are there? Please note we don't care about position, so we're going to consider like just how many starting 5s could you have. So this time you see that, does order matter here or not? I think the fact that it says we are not considering starting position, we're going to say order does not matter. We just have 9 guys, and then we're going to pick 5 of them, right? So we're going to use a function called combination here to calculate the number of ways. If we have 9 people, we can choose 5 of them. Now, in the TI-30s, I'm going to show you where these buttons are. Again, for this one up here, you're going to select the probability button. So if you have this calculator up here, you'll put in the 9 first, then you'll go here and you'll select the NCR key. So what we're looking for is NCR for this one. For those people who have this calculator, that NCR key is right here above the number 8. So you'll hit the number 9, then you'll go to that button, and then you'll put the number 5 in, and then you'll hit enter. So for the TI 83 or 84 people, I'm going to put the number 9 in first. I'm going to go to math, and we're going to arrow over to probability, and we're going to select this NCR key, and then the number 5. Hit enter. So we can see how many different teams are possible. There are 126 different teams, different combinations of starting 5s. All right, the last question we're going to take a look at is if there are 22 students in a class and you're going to select 3 students to be the president, vice president, and secretary, how many different students are possible, or combinations are possible for these roles? So here we have a lot of students. We have 22, and then we're going to be selecting how many? We're going to be selecting 3. But now, since we're assigning roles, president, vice president, and secretary, if I switch those roles, the order does matter here. So again, what we want to consider here is order does matter. So since order matters, what we're going to be doing is we're going to actually be doing what's called a permutation. Whoops. A permutation is the number of ways you can arrange things when the order does matter. This time, it's pretty similar to what we did up here in number 3, but this time, the difference is, here I just had one number. We were trying to find the ways we could arrange 5 books. Here you have 22, but we're only arranging groups of 3. So we use the letter P to correspond to permutation. We can see that the function we're going to do is what's called NPR, where N is the number we have to choose from, and R is the number that we were looking to choose. So on those calculators, again, for the TI-30s, you can find the NPR again right up here in this probability one. For those people who have this TI-30, it's right above the number 9. For the TI-83 people, again, we're going to go to that probability menu. So this one would be 22, and then I would go math, and we'd arrow over to the probability function, and we're going to go to NPR, and then we're permutating 3 things. And so there are 9,240 different arrangements of this. So the biggest trick here is knowing when it's a permutation or a combination this week. With this video, I do ask that you take the time, try to find these in your calculator, because if you're searching around for the buttons or trying to make it work, it's going to slow you down in class. So at least try to figure out how to get these different functions, how to get these different functions in here, whether it be the 5 factorial, the NC5, or the 22P3. Try to put those in and see if you can get what I get.